See, arrange the compounds in decreasing order of reactivity for nucleophilic attack. So if you want to get a nucleophilic attack, so you would see this is how it will be. Double bond O. Now there is some group here. There is some group here, and a nucleophile is going to go and attack here. The factors that dependent on nucleophilic attack is how much this carbon possesses high delta positive charge and how least is the crowding you will have here. These are the two factors which decides, isn't it? This we have discussed it long back as well, correct? So now, if you compare these four groups, which one has highest delta positive? So notice this one. If I take acid chloride will have withdrawing, acid chloride, in chlorine is withdrawing. Because of withdrawing nature, delta positive will be more. While aldehyde does not have any effect, while ketone will have some amount of plus psi as well as some bulkiness. And then we have ester. Ester we will have, plus m also, right, which is very strongly dominant, because of which, and some crowding also, because of which you will notice this is the least reactive. In fact, the least most reactive would be amines, R, NR2. This is the least reactive. Okay, guys. Now, if I have to put the order, then first one definitely is the where is it? First one definitely is the most reactive, then second one, then third one, and then fourth one. That is the option A. Clear? So remember, what are the factors that decides? Delta positive on the carbon and crowding. Second one. For this compound, you're reacting with something so that you're getting A. And that A is finally making a reduction with lithium aluminum hydride. And in that case, you're getting this particular compound here. Now, have you noticed something? That here, even after adding with lithium aluminum hydride, this compound is not getting reduced. I mean, sorry, this group is not getting reduced. Do you remember, this is only possible if there is an acetal group present on it, isn't it? Acetal group present on it. So which means the A must have been some acetal formation. So what should be X here? X has to be glycol. So if at all I take glycol in dry H plus, then you will get the compound A as like this with COO C2H5, and here this double bond will convert into this cyclic acetal form. Okay, so this is compound A. So question is, now when you reduce with lithium aluminum hydride, only this part, the ester part, will get reduced into alcohols, but this part does not get reduced. But thereafter, when you hydrolyze it, this part will come back as ketone. Okay, clear beta? Right, so that's how you will get this. So which is B. Next one. In the following reaction, NH2OH has been added. So what do we get? See, this is an aldehyde. And when you react with any nitrogen group which has two hydrogens on it, so this H2 and oxygen will dehydrate. So on dehydration, you will get this as NOH with H and pH. Okay. Now you could get cis form also, you could get trans form also. That means this is called syn and anti. If H and OH are on the same side, you call it as syn. If they are on the opposite side, you can get anti. So that means you can get both. It is coming from an aldehyde and forming an oxime. So if the compound is forming an oxime from aldehyde, it is called aldoxime. So what are we going to get? We are going to get a mixture of syn and anti-aldoximes. Make sense? Next. Acetophenone can be prepared by distillation of. First, recall what is the structure of acetophenone. PH, C double bond O, C, C double bond O CH3. This is called acetophenone. Now, if you want this, we need to have two acids. One C double bond O OH. The other one is CH3COOH. Now, these two acids has to first convert into calcium salt. So, like this. And then this on dry distillation, on heating, then you will notice carbon dioxide from here, calcium oxide from here will completely dehydrate. So as it dehydrates, what do we left with? pH C double bond O CH3 plus CaCO3. So this is how the product form. So what are those two acids what we need to take? One is benzoic acid, the other one is acetic acid. That particular form of salt. Check out, where is it? Now this is benzoate salt, acetate salt. So even the cross combination is possible, isn't it? So therefore, C is the best option we can have. Clear? Any doubt? Geminal dihalides on hydrolysis will give you what? Okay. Geminal dihalides. Geminal dihalides means halogens on the same carbon are called geminal dihalides. And this on hydrolysis, if you add water, so water will replace one with OH group. And this lone pair will push remove out chlorine, so that will give you keto group. So what are we going to get? We are going to get a keto form, which means a carbonyl compound is formed. Okay. Next, sixth, acetal or ketol is what? Okay. See, acetal or a ketol means you will have a group like this, right? OR and OR. What is this one? This is an alkoxide. At which position? Geminal position. So that is why it is called geminal dialkoxide. Cross Cannizzaro is an example of there is a redox reaction happening and it is a disproportionation also happening. That is what is called as cross Cannizzaro. Okay. Cross Cannizzaro, any example if at all we take? Okay. So notice this example. If you have HCOO, sorry, HCHO plus PHCHO, this is cross Cannizzaro. In this cross Cannizzaro, we know that this will become alcohol and this will become acid, HCO minus. Okay. Now, if you notice from here to here, carbon got oxidized. From here to here, carbon got reduced. So there is definitely a reduction reaction which is happening. Now, next thing, what is the other form we have? It is undergoing disproportionation. Now, when you are using the word cross Cannizzaro, that means you are only asking for this product. You are only asking for cross product. These are the cross product. In the cross product, there is no disproportionation. There is only redox reaction, but there is no disproportionation. Disproportionation means same molecule should give you oxidation as well as reduction. So that's not happening. So therefore, this is no disproportionation. Only one thing is happening, that is redox reaction. Acetaldehyde can be converted into this form by which reagent? Okay. This is one thing we discussed. That is, this reaction is called Tollens reaction. This is called Tollens reaction. Let me show you how does that happen. If I need to get acetaldehyde, that is CH3, CH3, CHO, and react with HCHO, this is first mole. So when you react the first mole, aldol will happen. Aldol condensation will happen. So that means we will get CH3, CHOH connected with C, sorry, this one, CH3 minus connected with this one. So what do I get? We will get CHO, CHO and CH2 connected with CH2OH. This is the first form you will get. Basically, this hydrogen is lost, and carbon from this position is going to attack this carbon position. So that's how we get first aldol. And this, if you present in further aldehyde, second mole. Now this is second mole with OH minus. So now one more alpha hydrogen is there. So this time this carbon will go attack this carbon. So that makes it OHC connected with CH with CH2OH and one more CH2OH. So 2 moles done. Now again, if you react with HCHO with OH minus, one more hydrogen is there. You can remove this carbon. So this will attack one more time. So you will get OHC. Now C has one OH like this, one OH like this. Now I got one more OH. From here, if I go with the fourth mole, this is the fourth mole, this will give you Can0 now. Why Can0? Because now this carbon does not have any alpha hydrogen. So because of which, now this part will become alcohol as well, like this, like this, and like this. And one mole, this will become HCO minus, which is the fourth mole. This is called Tollens reaction. Clear? My suggestion is you better practice this. Once watch it and try it on your own. Both of you. See the next one. Which of the following combinations will give propanaldehyde on dry distillation? Let us see both of them. If these two will make a cross or cross distillation here between these two, the distillation will become PHC double bond O, and from here H will come. So for option 8 is benzaldehyde, correct. And what about option B? For option B, what do I get? If at all I remove carbon dioxide from here and oxygen from here, so I will get CH3, C double bond O, C2H5. So that means I will have 2 butanone, right? So then C, here if at all I remove carbon dioxide and connect with this C double bond O, I will get this as CH3, CH2, C double bond OH. So I'll get propanaldehyde. D option, I will get CH3, C double bond O, and CH3. So I'll get acetone, right? Are you comfortable understanding how the distillation products are coming? Right? Is that clear, beta? Right. So which one is our option here? C, because we require propanaldehyde. Hmm. Next. In this reaction, concentrated H2SO4 distillation, what will it do? Remember, again, if you don't remember, please remember that. Let us try to recall that. If you take 1 mole in acetone, 1 mole of HCl, 1 mole of HCl, and sorry, 2 moles of acetone with HCl, if you take, you will get mesitile oxide. If you get 3 moles, 4 ohm. If you get 3 moles in concentrated H2SO4, you'll get mesitylene. Okay, chalo, quickly recall, write along with me and recall. Okay. First, this is the reaction you need to recall. If I take acetone plus acetone, 2 moles in dry HCl, correct? So in that case, the product what you will get is like this. This is called mesityle oxide. Okay. Suppose if I take 3 moles, if I put same reaction here, but this time I took 3 moles, so that means 2 moles here and 1 more. So in that case, this will again react with one more group and convert into this form of double bond. This is called forone. This is called forone. But if I take 3 moles of acetone in concentrated H plus, then dehydration will happen such a way that you will get mesitylene. This is called mesitylene. First read what I have written, then try to write it on your own. Okay, please do that. Okay, right, let's see now. Could you please explain the last one again? Which one? Last one means this one. How we get mesitylene or how we get forone or all? This one. Okay. See, mesitylene is in a form where we first convert this into an enol. Imagine keeping this in an enol form like this. Okay, like this we have OH double bond, OH, OH with a double bond, OH with a double bond. Okay. Now imagine protonation happens here first. Correct? Sorry. Protonation happens here first. This will try to go as OH2. Okay. So that's where this pi bond will attack here. This will try to go as OH2. That's where this pi bond will attack here. This will try to go as OH2, and that's where this pi bond attacks here. So what is the ring size now? 1. Got it? 2. Sorry. 1, 2, 3, 4, 5, 6. Correct? This is the ring size what I got. So I will get this into a cyclic structure, and OH2 is gone in all these 3 cases. So if OH2 is gone, what is left in that case? There is one methyl, methyl, and methyl left. Okay. And obviously, if the pi bond has gone, there is one positive charge here, and positive charge here. And this on heating in the presence of concentrated H2SO4 will undergo elimination. So you will get double bond here, double bond here, double bond here. So what are we getting? Mesitylene. Clear? So instead of actually going through a regular route of aldol, it will go through the dehydration route. Okay, beta? Next. Grignard's reagent cannot be giving carbonyl compounds in which particular case? Important. Hmm? See, normally Grignard's reagent, if we react with any acid chloride or something, they all will form first aldehyde or a ketone, and thereafter they'll go into alcohol. So that means we definitely can get through a route of aldehydes and ketones. But what about with carbon dioxide? See, if you are treating with carbon dioxide, RMgX, which has minus and plus charge here, carbon dioxide is C double bond O, C double bond O. So this minus is attacking here, pi bond is moving. That way, I will get this as RCO minus double bond O. So what we are getting is already an acid group, right? So already we got as an acid group here. So therefore, we will not be able to convert that back into aldehyde. So which one is that? This one. Okay. Next. The product of the reaction here. So let's see what is the product we are expecting. I have C double bond O here. If you remember that this is a benzaldehyde derivative, and here there is an anhydride formation. Okay. And if you remember in the anhydride formation, there is a H2 group here. If at all there is an H2 group here and there is an oxygen here, these two can be eliminated out and then they can be combined with double bond here. So with phenyl group here, and then rest of the group is actually C double bond O, OH, plus the other group will be PHCOOH. What is this one? This is like a cinnamic acid, isn't it? In fact, this is cinnamic acid with a nitro substitution. Clear? Phenyl and nitro substitution. This reaction, remember what do we call it? Perkins reaction. It is called Perkins reaction. Okay, clear? Again, quickly recall Perkins reaction and write it once. See, I'll give you the original reaction, what it is. So if you have a benzaldehyde, CHO, with acetic anhydride, that is CH2, let me write down this way. HH with HC double bond O, OC double bond O, CH3 in the presence of CH3 COO minus and heat. Here also it is like, some kind of an aldol form where you remove this water molecule, and as you remove it out, so what do we get here is CH double bond CH COOH, and here the bond will break to make it as COOH. Yeah? This is called cinnamic acid. Please write down Perkins reaction, practice it quickly, watch it, and once practice it, what is Perkins reaction? Finished? Next. Cyanohydrin of which compound on hydrolysis will give lactic acid? Okay. So I need to first check out what exactly is lactic acid, and from there we can get to see, you know, see, if you have a carbon, lactic acid is when you have C with OH group, COOH group present on the same carbon with H and a methyl group. If you have this way, then this is lactic acid. Okay, lactic acid. So it is simply beta hydroxy, propanoic acid. That is called lactic acid. So how would I get that? Simple. If I take this, react with HCN, right, followed by acidic hydrolysis. That's it. Because HCN will give you CH3, CH, OH, and cyanide. And you know that cyanide on hydrolysis will give you acids. Done. So which one is giving lactic acid? This one. Okay. Next. In the reaction, we are treating first with NaBH4. And you know that NaBH4 will only reduce the ketone. It does not disturb the double bond. So the X product, what you will get here will be a double bond which is left like that. But here it will become alcohol. Thereafter, BH3 H2O H plus, this is basically hydroboration oxidation. And if you remember, hydroboration oxidation is a anti-Markovnikov addition. So which means on the double bond you will add with an anti-Markovnikov way, this way, and you'll get this as OH. Clear? Now notice this kind of a structure, where is it present? Oh, sorry. I made a mistake here. This is not peroxide given. This is not oxidation. This is reduction. First BH3 will form. In acidic medium, it will go reduction. In basic medium, that is in peroxide, it will go oxidation. So here instead of OH, we will get only H. So H means what? We have CH3. This is CH3 and OH which is present. So answer is C. Check. Clear? Acetaldehyde cannot give which one? Which reaction? Acetaldehyde means CH3CHO. It has an open methyl group, so definitely it will give iodoform. It cannot give any Lucas test because Lucas test is for alcohols, not for aldehydes and ketones. It can give Benedict test. Benedict test is going to give, it can give Tollens test. Okay. Tollens test is silver mirror test. Benedict test is brick red color formation, Cu2O. Hmm. Next. Compound, this compound formed from the reaction of furfural with ethanol is. Okay. Now, if you notice this particular compound here, this is ethoxy, and then we have OH group on that same carbon here. This on furfural, what would happen? Okay. See, let me on this part. Yeah. So here we have an aldehyde. This is an hemiacetal. Can you notice this is an hemiacetal? Hemiacetal on reaction with ethanol. What do I get? Okay. Sorry, I meant to say first you had an acetal here. Okay. And that when you're reacting with ethanol here in the presence of dry H plus, this is what has been asked. So you will have to make a hemiacetal, which is the given product, which is CH and ethanol. Ethanol will be O C2H5. The other part will be OH, and which is clearly what is been given. This is ethoxy, and there is a OH group here, correct? So to get this product, I mean to get this acetal, what did we use? We use ethanol. So what is this product actually? A question asked is what is product here? This is acetal. So this acetal is the one which on hydrolysis again, if you do the hydrolysis again, acidic hydrolysis, you will get furfural back. Okay. So what is that forming here? Acetal. Okay. So it's going to form an acetal. Okay. Sorry. Hemiacetal. This is one OH group is there, no? But one OH group is there means it is hemiacetal. Hemiacetal. Next, a compound with a molecular formula does not give litmus test. Okay, that means there is no alcohol in it and does not give color with 2,4-DNP. That means there is no aldehyde or ketone form also. It does not, it reacts with excess of MeCOCl to give a compound. So it will react with this excess of this one to give a compound whose vapor density is 152. Compound A contains how many hydroxyl groups? Okay. So let's see how we can figure out here how many hydroxy groups we have. Okay. For that, first we need to figure out what is the molar mass here. Okay. So if you notice if you check out what is the molecular mass here, 8 into 12 plus 18 plus 64. Correct. Right. So this is 96 plus 18 plus 64. So that makes it 414 plus 64, which is 178. Clear? So this is the molar mass which we have. Okay. Now, if the vapor density is this much, then molecular weight of this final compound will be how much? Molecular weight will be equal to vapor density times of 2. Okay. So that is giving us 304. So this is 304 molar mass. So initially the molar mass is this much. After the reaction with excess of methyl chloride, this is how much we have. So do you remember the number of hydroxyl group formula? The number of OH groups will be equal to, okay, final molar mass by minus initial molar mass by 42. Because at every oxygen you will have acetate amount, that is CH3CO amount of increment in molar mass. So therefore it is 304 minus 178 divided by 42. Correct? Any doubt here? So how much we are getting? Approximately we are getting it as 3. Any doubt on the 17th one? Next. NaBH4 is being treated here. So see, at this position, when H minus gets added, H minus is getting added, then you will have this oxygen becoming OH because of water. So that carbon will become a chiral center actually. So in that chiral center, if you notice, this configuration is not changing, but here I can make as OH coming outside, and here I can make an OH going inside this way. Okay, these are the products you can get. What are these two products? Diastereomers, because they are not mirror images of each other. So what would that be? Diastereomers. Okay, beta. Any issue on 18th? See 19th. Which of the following does not form a stable hydrate by the addition of H2O? Okay. All these examples we discussed. This also we discussed. I'll show you the structures. Okay. Basically, you will have this middle C double bond O will become an hydrate here like this, O and H in the in aqueous solution, and this will be double bond O with pH and pH. So here you will see a hydrogen bonding forming. Because of this strong hydrogen bonding, its hydrate is very, very stable. Same way, this is called nin hydrate. In the nin hydrate, at this position of the oxygen, you will get OH and OH, which will give strong hydrogen bonding. Here there is not hydrogen bonding. Here it is the ring strain release. Okay. So because this angle is expected to be 120, now it is expected to be 109. So which means definitely there is a release of strain here. So because of which this is more stable. Okay. The least stable one is which one? This one. Okay. Here there is no stability factors coming into picture. Okay. So that will be D. Then next, the conversion from here to here. How do we, that can be affected by using reagents. Which reagents? Okay. If it is basically an oxygen getting inserted at the center. Now what do we call this kind? This is called Baeyer-Villiger oxidation. This is called Baeyer-Villiger oxidation. So wherein if we use any peroxy acid, that is, any RCO3H, any peroxy acid, there will be an insertion of oxygen like this. This is the product form. Okay. So out of the four given, which is a peroxy acid, the last one, see, it has CO3H. Clear about Baeyer-Villiger oxidation? Next. If you have chlorination done in a basic medium, 1:1, okay, you know that when it comes to chlorine, chlorine will always get added at replace all the hydrogens when it comes to basic medium. So in basic medium, you will get chlorine here, and these two, nothing will happen. But in acidic medium, whether you give 1 mole, 10 moles, any excess number of moles, only one substitution is possible. Only one substitution is possible. Even if you give excess also, you will get the same thing. Got it? So which are the correct options? Only C. Please check. If you don't recall anything, or if you have any doubt in here, any confusion, please do ask. They are clear? Right. Just now we have discussed Tollens reaction. This is the Tollens reaction again. You can see we are using acetaldehyde with 4 moles of this one. So we should get what? That swastik form, isn't it? So we should get that swastik form here. Huh. Once you get that swastik form, he is asking about the next product. This is very interesting. See, what we call it in Tollens reaction is this one. Okay. This is the product we got. Right? Clear. Now, when you are reacting with 2 moles of this aldehyde, can you see this is a very similar to that of glycol? So it can give an acetal formation. So how does the acetal formation observe? See, here, if you notice, there are 5 carbons on total. 1, 2, 3, 4, 5. Barabar? 5 carbons. Now, here there is an oxygen, which can make a acetal like this. Clear? Similarly, here there is an oxygen, right? Here there is an oxygen, and it can make an acetal like this. Check properly. Clear, beta? This is what you will get. Okay. Now, this is some kind of a spiro ring. This is a spiro ring. This is a spiro ring, correct? Hmm? Tell me, can 2 spiro rings like this? One spiro ring is like this, correct? So if this is coming out of the plane like this part is completely coming out of the plane here, imagine. Okay. Then the other ring should be on the plane like this, correct? Okay. And on the plane means this methyl should go inside, one methyl should come outside. But here, both the methyl should be on the same plane this way, correct? Any doubt here? Okay. So now tell me, total number of stereoisomers of the major product is how many? Okay. Right. Sorry, one of them is H. This is H. One of them is H here because this is acetaldehyde, correct? Hmm. Okay. Now, can you tell me that is there any plane of symmetry here? No, right? There is no plane of symmetry because both of them are not methyl. One of them is hydrogen. Okay. So here, one of them is hydrogen. So have you noticed that this is like an alene form? An alene form does not have any plane of symmetry, neither center of symmetry. No plane of symmetry, no center of symmetry. So that means this molecule's mirror image is a non-superimposable mirror image. So what are the products you will get? 2 products you will get. Okay. Very important JEE Advanced 2024 question. Okay. Clear? Done? Hmm. See the next one. An organic compound C5H10O reacts with hydrazine to form hydrazone derivative. Okay. So this would react with hydrazine to form hydrazone derivative. That means it has to be an aldehyde or a ketone. Then only hydrazine will react. The hydrazone on being heated with KOH gives N-pentane. Okay. The compound A does not respond positively to Tollens reagent. Acha, if this is not responding positively to Tollens reagent and neither to iodoform test, that means it is a ketone without a methyl group. So it has to be ketone without a methyl group, correct? So if 5 carbon are there and I need to make a ketone without a methyl group, this is the only possibility I have. Check. Isn't it? Otherwise, I need to, put some kind of methyl on any of the side. If you put methyl, that means it will give iodoform. So answer is this one. So it is directly given from the second hint itself. What is the answer? Answer is C. But nevertheless, we'll try to see what is the product, how it is forming. See, check out. If at all I treat with hydrazine, NH2, NH2, hydrazine will make this as double bond N and NH2. This is called hydrazone. This is what we call it as hydrazone. Okay. And you notice that this on heated with, KOH. Have you noticed that this form with KOH is nothing but Wolff-Kishner reduction? So in Wolff-Kishner reduction, what do we get? We will get this as an alkane. So that means you'll get H and H. So what are we getting this one? This one is N-pentane. So this is the reaction given. So two ways you can get the hint. Even from this N-pentane also you get the hint that there is a Wolff-Kishner. This must be the reactant. Or in the second part is also a hint. If there is no positive Tollens test, that means it has to be ketone. And if it is not giving iodoform, that means there must not be any methyl group. Okay. Done, beta. See the next question. Compound having dipole moment, highest dipole moment. See, here the pi bond is moving from here to here. So definitely this side you'll have positive charge, this side you'll have negative charge. So there is a dipole moment in this direction. But the most dipole will be in the B group, because here, if at all I keep a complete positive and complete negative charge, then the ring will become aromatic. That's why the compound, this compound will exist in this way, which means it will have a high dipole moment. Okay. So aromatic is the cause here. Clear? Hmm. Next one. You have a cyclic ester and you're trying to react with excess amount of methyl chloride. Okay. So let me just take this away and bring it down here. Let me show you how this would work. So if you notice that excess amount of methyl means this part will definitely become alcohol, and this carbon will have two times of methyl groups, and then we'll get OH, correct? This is the excess amount of uh, methylation. So because of which you will get alcohol, two alcohols. And now you are trying to react with concentrated H2SO4. So what will it do? Concentrated H2SO4 will try to dehydrate this compound. Okay. So where is the dehydration happens? Here. OH2 plus will come. This group will go away. And that's where the lone pair of oxygen will connect. Lone pair will oxygen will connect. So now the 5-membered ring earlier, now it will become 1, 2, 3, 4, 5, 6. So it will end up getting a 6-membered ring with an oxygen and two methyl groups like this. So this is a product B. Clear? Where is that? This one, A. Okay. Again, this is also a JEE question. Meg, one of the questions which you have posted, beta, it has a very similar type of thing. Hmm? Got it? I'll explain that anyway. Next, check out 26 to 28. An alkene on ozonolysis is giving this one. So that means you're breaking that. So it is definitely somewhere at the equal part. So there is only one double bond. And B also is obtained by hydrolysis of the product obtained by reaction between cyanobenzene and CH3 MgBr. Okay. So let us do that first. Okay. I'll add a page here. See here what's happening. This is question number 26. As per this, it is said that if you have a cyanobenzene is CN, and that reacting with an Grignard's reagent, which is CH3 MgBr, CH3 MgBr. You know that in Grignard's reagent, with cyanides, you can never get an aldehyde. You can never get an alcohol, you'll only get aldehyde. So, aldehyde or a ketone. So, C double bond of CH3. This is the product form after hydrolysis has been done. Stepwise, if you ask me, the first step is CH3 will go attack. So, you will get CH3 double bond N minus MgBr plus. But on this, the second mole cannot attack because now the carbon is not sufficiently positive charge. That's why hydrolysis will happen directly from this step, which will lead to formation of acetophenone. This is acetophenone. Now, what is been the question said is that this acetophenone is also forming from ozonolysis. So, which means how should that compound has to be pH CH3 double bond pH CH3. Check this out. If this compound is made reductive ozonolysis, you will break the bond from here and you will get 2 moles of PHC double bond of CH3. That is a product. So what is the reactant? This is a reactant. Okay. Again, this is a JEE question. So please check this out. How to solve the 26th one. Okay. So read out once. If you want, I'll just put this entire thing here. So refer the question and see the solution once. What is A is clear or no? Let me mark what are A, B, C, D here. This is A. Okay. And this is B. Okay. Now what is C? See, C is simple. If this is been further oxidized in the presence of selenium dioxide, you know that selenium dioxide will make an oxidation at the alpha position. So you will get this one. So this is C. Now check out what are all the options correct for ABC. Which is not correct about A? A is optically inactive. That is correct. On catalytic hydrogenation, transform of A produces racemic mixture. Catalytic hydrogenation transform of A. Oh, okay. So that means if you take a trans here, this is how it is. Suppose double bond O. If you have pH and pH here, methyl and methyl here. Suppose if you take this one, you know that this is trans. Trans plus H2. H2 addition in the presence of metal is what? In the presence of metal surface, that is catalytic metal thing will be TST, right? That is 3O. So 3O means like this. So which is pH with methyl and methyl with hydrogen and hydrogen. Of course, here this could be plus or minus. So that means this is racemic mixture. Hence, this option is also correct. A can be prepared by Wittig reaction of acetophenone with this compound. That is also correct. See, acetophenone is like this. pH CH3 double bond O. Now that when you react with pH thrice P double bond C CH3PH. Okay. And if you remember, this is called Wittig reaction. I told you, only remember it like a shortcut. You just need to remove this part of it and join the rest. So on joining, what do I get? I'll get double bond C here with CH3PH. And here we'll have PH CH3. So that plus P PH3O. So P double bond O, PPH thrice. This is the final product yield. So yes, this product is also formed. Okay. Next. On treatment with per acid followed by hydrolysis, transform of A produces racemic mixture. Okay. Suppose if I take this same transform, okay, if at all I take this transform and then react with a peroxy acid, PHCO3H. Peroxy acid will give you syn epoxidation. Syn epoxidation means I will have like this oxygen with phenyl and methyl and phenyl and methyl. And as per the question, it said follow the hydrolysis also. Follow the hydrolysis as well. Okay. Now tell me, will these two will be on the same side or on the opposite side here? ध्यान से देखना. This is a trans. I make a syn addition. So I should get 3O kind, right? So 3O kind means if this is coming out of the plane, then this phenyl has to be inside the plane. Okay. Same way, like this. Here, methyl should be here. Phenyl should be here. Correct? Isn't it? And now, this is like a transform now. This is still in a transform. Okay, it is basically 3O, but because it is cyclic, we can express its transform also. So on a transform, hydrolysis is an anti-addition. So if I make an anti-addition, what should I get? I should get erythro, isn't it? So if I get erythro here like this, we should have pH and pH, methyl and methyl. Then we have OH and OH on the same side. So what are we getting here? Because there is a plane of symmetry, the product what we got is a meso. So this is a erythro whose name is meso. I mean, whose property is mesoform. Clear? So please check with the last option here. What is it? What is being said? On treatment with this one, it will give racemic mixture. Is it giving racemic mixture? No. So these three statements are correct, but D statement is wrong. Okay. Girls, please correlate with the question. Check if you have understood every option of 26. Check 27 now. Which is correct about B? What is B? This one is that keto form. B, it gives iodoform, which is true. Okay, because there is an open methyl group. On treatment with lithium aluminum hydride, H2O, it produces a compound which also responds to iodoform. That is also true. Why? Because it will become alcohol. Here you will get OH, but you still have an open methyl, so that will give you iodoform. It gives Tollens reaction. No, because Tollens reaction is only given by aldehydes here. On treatment with NH2NH2 alcoholic KOH, it produces ethyl benzene. That is true. Wolff-Kishner reduction. So only incorrect option is that C, which is Tollens reaction. Girls, clear?
Yes, sir.
Right. Last one, what about the option C here? Okay. Let me pull this C which we worked out already. So this is compound C. On treatment with NaBH4, it will produce a diol, which is true because this will also become alcohol. This will also become alcohol. On treatment with OH minus concentrated followed by acidification, the racemic mixture of carboxylic acid is obtained. Okay, now this is interesting. We have PH, C double bond O, C double bond O, H is there here. Okay, and then I will push OH minus here. So OH minus will go attach here. So we'll get PH, C double bond O, O minus, OH and H. Remember, as soon as it goes here, H minus will go away and that will push here. So what do we left? PH, C, O minus, with H and C double bond O OH. And obviously this O minus internally takes H plus. So we will get this as OH, H and CO minus. Okay. So can you see there is a chiral center? What is this one? This is intramolecular Canizero. Intramolecular Canizero. Okay. On treatment with OH minus followed by this one, you will get this carboxylic acid is upturned, which is true. Next, it gives Tollens test. That is also true because it is an aldehyde. Basically, it is an aldehyde form, so it has to give Tollens test. It can take part in aldol condensation. No, because there is no alpha hydrogen. Here, is there any alpha hydrogen? No. So, no alpha hydrogen. So, hence, no aldol condensation will take place. Clear? Now, I suggest this reaction B is very important, which is intramolecular Canizero. So, please uh, understand that and try to reproduce it once. Check it out. The next one, benzaldehyde with HCN is giving two isomeric compounds. Both nitrile and isonitrile compounds are possible with HCN reacting with carbonyl group. Okay, so let us try to decode what exactly it is trying to say. Let me push it to the new page. So suppose if you have a benzaldehyde like this, and that when you react with HCN, so first it will form a cyanohydrin, so which is CH, OH and cyanide. Okay, and what does it say? Okay, what are the options given? Hmm. Hmm. Once you get a cyanohydrin here, we are noticing that there is a chiral center, so definitely you will have two stereoisomers. So first statement is okay. Okay. Oh, okay. So second statement is when you react with HCN, is the nitrogen group going to attack on the carbon is what is the question. Okay. No, it is not going to happen. Instead, hydrogen which is connected as C triple bond N here. First, the pi bond, I mean the sigma bond will break onto carbon. This is the negative charge which will go and attack. So only nitriles can form. Isonitriles are not formed. So therefore, this statement is incorrect. Okay. Next. See this 30th question. With NaOH, you are expecting a Cannizzaro reaction. Is it possible? No. Reason being, when it comes, this is called chloral. In the presence of chloral, when OH minus gets attached here, then instead of H minus going away, right, which one will go? CCl3 minus will go away because this is a good leaving group. So this will go away and becomes HCOOH, wherein this minus will take H plus becomes HCO minus plus CHCl3. So what is this one? Halo form. Correct. So it will go to an halo form reaction and not to the given reaction. Okay. There are no alpha hydrogens in this reaction, so it cannot give aldol. So which is true because minimum condition is this should have at least one alpha hydrogen, which is not there. So no aldol will take place. Okay. Also, any doubt here?